To test whether a table shows direct variation, what we're going to look for is we're going to look for a common ratio between our x and y values. When we solve the direct variation equation, which is y equals a times x for a, we get this, a equals y divided by x, and a, remember, is our constant of variation, which is kind of the same as slope. So let's take a look at our table, and what I'm going to go do real quick, because I'm going to do this in my head, is go through and do all the y values divided by the x values. Make sure you do that in that order with the y on top and the x on bottom. So as I go through this, I can see when I divide y by x, I'm getting -2 and -2, and then I'm getting -2 all the way across the board. So what that is telling me is that yes, this table does show direct variation because I have that common ratio. If I want to go one step further, I can even say that I know the constant of variation. The constant of variation is that number that you found, which in this case is -2. And if I want to go even one step further than that, I could say if I want to write the equation of this, I know it's going to be y equals -2 times x is the equation. Now again, just be really careful that you do y divided by x. If you flip it and do this the incorrect way and do x divided by y instead, you'll see that you'll sort of get one of the answers right. Each time you divide, you're going to get a ratio of -1/2 when you do that, and you'll get that all the way across the board, which may lead you to believe that yes, it is direct variation, which is true, but you're also going to then maybe say that a is -1/2, and it definitely is not. So make sure you divide the correct way. Next, let's try a real-life problem and see if we can use what we just talked about with testing for direct variation to see if it works in this case. So in this particular example, you are examining the tooth length of a shark, hopefully a tooth you just found on the beach and not still in the shark's mouth, and then the body length of a shark. And we want to look and see if there is some evidence of direct variation. So again, we're going to go through this and test for a common ratio by dividing the y value by the x value, or in this case, the b value, the body length, divided by the t value. So let's go through and divide. I already worked ahead and did mine, so if you want to pause the video and try to divide for yourself, that's fine. Otherwise, here were the ratios that I found, and I just rounded to the nearest whole number. So I'm going to just go through and jot those down. I got 119, I'll put approximately 119, approximately 121, another 121. This one worked out to be 119. 120 and then 120. So again, if you don't believe me, pause the video, try to divide that by yourself and see what happens. So now I have to make a decision. I have to see if this table is showing me evidence of direct variation. Now we just said we had to have the same ratio when we divided, and obviously we can see we don't have the same exact numbers across the board. But remember, real life is messy and things don't always work out exactly the same in real life. So if I was a shark scientist studying this, I would probably say that yeah, there probably is some evidence of direct variation because the numbers are all fairly close together. Like I said, it's a real life problem, so sometimes real life is messy. Since I'm going to say it's direct variation, I want to go ahead and I want to find an a value. Now there's a couple ways you could do it. For me, since I'm not a shark scientist, I would probably just look at my a values and say, they're all about 120. If I wanted to be more accurate, maybe I'd want to find an average of those and get an average a value. But once I have that, however I'm going to do it, I'm going to say it's about 120. I can actually go one step further than and write an equation for this. Remember, it's y equals a times x, or in this case, b equals a times x. We're going to say b is about 120, and then times the tooth length. So I can use this equation then, if my results are accurate, to predict some other body lengths of sharks based on the teeth I might find.